Two-Point Perspective, a first quarter project for pre-IB advanced algebra by Jack Ford, period 2. First we'll talk about the original picture that I drew, which is of the TARDIS from Doctor Who. After that we'll talk about the equations I've figured out for the lines that I marked 1 through 7. After that we'll talk about the domain and ranges for those lines. After that I'll show you the pictures, the original picture after I've altered its horizon and vanishing point. If you're watching on YouTube, you can click on the titles to skip to that part of the video. So if you wanted to watch the original picture, you would just click on the original picture and it would take you there. This is the original drawing. As you can see, it's just a very basic little drawing. It's got very minimal shading. There's lines all about the place, and some lines have been marked as 1 through 7. I have 5 oblique lines and 2 vertical lines. Here's a closer look at the picture and at which lines I'm demarcating as 1 through 7. In order to find the equation of the line, of course, I'm going to need the coordinate plane. For that, I've decided to use this. The y-axis will go right through the central axis, the central line, sorry, and the x-axis will be the horizon. These are the equations I found for the lines 1 through 3. For line 1, the endpoints are 0, 12, and negative 6.5, 4.75. To find the slope, you just subtract the 2 y values and then divide it by subtracting the 2 x values. After I did that, I got a slope of 29/26. The y-intercept on the graph, it crosses at 0, 12, so b equals 12. After that, the equation that I got was y equals 29/26x plus 12, and that's 29 over 26 times x plus 12. On line 2, the endpoints were 0, 12 again, and positive 6.5, 4.75. This was just the reverse form of line 1. The slope, again, found in the same form as line 1, just with the positive 6.5 instead of the negative 6.5. When we got that, we got negative 29/26 instead of positive 29/26. The y-intercept still crosses at 12 on the graph. So the equation is just y equals negative 29/26x plus 12, and that's negative 29 over 26 times x plus 12. For line 3, the endpoints were 0 and negative 10.5, and negative 7.25, and negative 3.75. The slope is just negative 10.5 minus a negative 3.75, which is negative 6.75, divided by 0 minus a negative 7.25, which is just 7.25. After that, then we find that the slope is negative 27/29. Y-intercept crosses at 0, negative 10.5 on the graph, so b is negative 10.5. After we plug those back into the equation, we find that the equation is y equals negative 27/29x minus 10.5. Again, that's negative 27 over 29 times x minus 10.5. Here are the equations for lines 4 through 6. For line 4, the endpoints were 0 and negative 10.5, just like line 3, and 7.25 and negative 3.75. Just again, line 4 is just the inverse of line 3. The slope is figured out the same way as line 3, so just negative 10.5 minus a negative 3.75, which is negative 6.75. Then we have divided by 0 minus 7.25 minus a positive 7.25, which is a negative 7.25. So instead of a negative 27/29 for the slope, it's instead of a positive 27/27. Y-intercept crosses at 0, negative 10.5 on the graph, just like line 4. So B is still negative 10.5. So when we plug those back into the equation, it's just positive 27/29x minus 10.5. Again, that's 27 over 29 times x minus 10.5. For line 5, the endpoints were 4, negative 4.75, and 6, negative 3.5. The slope is found the same way as lines 1 through 4, just taking the y values and subtracting them, then dividing that by subtracting the two x values. In this case, negative 4.75 minus a negative 3.5 equals negative 1.25. Divide that by 4 minus 6, which is negative 2. After that, we find that the slope is 5/8, or written in decimal form is 6.25. The only reason I didn't write the other ones in decimal form was because dividing by 29 would have left me with a very long decimal. The y-intercept is just negative. We can find the y-intercept by plugging in the values for one coordinate along with the slope that we've already found, and then just into the y equals mx plus b form, and then just isolate the variable b. After doing this, we find that the y-intercept would be negative 7.25. Plugging this back into the equation, we find that the equation of line 5 is y equals 0.625x minus 7.25. Again, that's 0.625 times x minus 7.25. In line 6, the endpoints are 7, 3.5, and 7, negative 3.5. This is a vertical line, so the slope is undefined because we are dividing by 0. The y-intercept, it will never cross the y-axis because it is a vertical line and the x value doesn't equal 0, so x just equals 7. No matter how far up you go in the graph, x will always be 7. For line 7, the endpoints were negative 7, 3.5, and negative 7, negative 3.5. Again, just the opposite form of line 6. But still, the slope is undefined, and the y-intercept is just the opposite of that, so negative 7 instead of 7. But again, since it is a vertical line, there is no y equals mx plus b form for it. Now let's move on to domain and range. The domain for line 1 is negative 6.5 is less than or equal to x is less than or equal to 0, because the least x value in line 1 was negative 6.5 and the greatest was 0. The range for line 1 is 4.75 is less than or equal to y is less than or equal to 12, because 4.75 was the least y value in line 1 and 12 was the greatest. In line 2, the domain is 0 is less than or equal to x is less than or equal to 6.5, because 0 was the least x value in line 2 and 6.5 is the greatest. For the range, 4.75 is less than or equal to y is less than or equal to 12, because 4.75 was the least and 12 was the greatest y value. In line 3, the domain is negative 7.25 is less than or equal to x is less than or equal to 0, because, once again, negative 7.25 was the least x value and 0 was the greatest in line 3. For range, we have negative 10.75 is less than or equal to y is less than or equal to negative 3.75. Because, once again, negative 10.75 is the least value, the least y value in line 3, and negative 3.75 is the greatest. These are the domain and ranges for lines 4 through 6. The domain for line 4 is 0 is less than or equal to x is less than or equal to 7.25, because, as I've explained before, 0 is the least x value and 7.25 is the greatest. The range for line 4 is negative 10.75 is less than or equal to y is less than or equal to negative 3.75, and as I'll explain for the last time, negative 10.75 is the least y value and negative 3.75 is the greatest. Moving on to line 5, the domain is 4 is less than or equal to x is less than or equal to 6, and the range is negative 4.75 is less than or equal to y is less than or equal to negative 3.5. In line 6, the domain is only x equals 7 because there is no other value for x which we are shown. And the range is simply negative 3.5 is less than or equal to y is less than or equal to 3.5. The domain and range for line 7 is that the domain is x equals negative 7 and the range is negative 3.5 is less than or equal to y is less than or equal to 3.5. This is my version of the original picture by moving the horizon up by 2 units. I kept the length and position of all vertical lines intact. By doing so, the bottom half seemed like it was distended by a lot and stretched out. The big 2 lines on the bottom seemed to be at way more of an angle to each other than the ones in the original picture. On the other hand, the top half seemed squished and compacted downwards in comparison to the original. For instance, the top 2 lines are at a more relaxed angle than they were in the original. This is my version of the picture after altering the vanishing points. Move the 2 vanishing points on either end in by 1 unit on each side, so the line of horizon is still centered, but 2 units shorter, once again keeping all vertical lines in the same place and with the same length. Well, at first you don't notice a large difference. If you look closer, you see that the whole picture has just been squished or compacted a bit. Lines are all at a bit more of a sharper angle. And that concludes my presentation. Hopefully you enjoyed this if you're watching on YouTube, which I don't really understand why, and my math teacher, thank you for taking the time to view my project. I hope that you appreciate, and hopefully I got a good grade. Thank you, and have a nice day.